completed how to construct LR0 parts table, right? So I just want to clear some points how to construct LR parts table and all. So that's what I have conducted this session. And now we'll see one problem, like we'll see one grammar and how to construct the LR0 parts table for it. And then we'll see like how the bottom of parser will construct a parts tree for a string. Okay, so that's the main concept. And this procedure, no, this shift reduce parsing procedure, we can call it as a shift reduce parsing. This procedure is common for all the four bottom of parsers: LR, SLR, LDLR, and CLR. And later on, we'll discuss at which point all the parsers are different. Okay. So today we'll just for refreshing the concept. Just we'll see one problem, how we are going to construct the LR0 parts table, and we'll see how to do the parsing. Okay. This parsing procedure is common for all the four parsers. Like what are the bottom up parsers are there for all the bottom up parser? This procedure is common. Okay, so if your friends have not joined, ask them to join, because this procedure will be common for all the four parsers. Okay, so let me do one thing. Just wait for a moment. My screen is visible to you. Okay. Now we'll see like how to construct LR0 parser. And in the first class, we have discussed how to construct LR0 parsers and all. And here we have seen, like in last class, we have seen some parser. For this grammar, we have seen how to construct LR0 parser, and later how to construct DFA from it. And for the DFA, we have constructed the parts table. So that thing we have completed in the last class, right? So while construction of this DFA, you may get some number of questions. If you have done with some examples that we have discussed in LL1 parsing, if you have tried to construct the parts table for the same grammar that we have discussed in LL1, then by the time I think you might have some doubts in your mind. Okay, if you have not solved any question, then it's okay, fine. Definitely you won't get anything. Okay, so if you have solved some problem, definitely you might have some questions in your mind. So according to as per that problems, like I have taken one problem, and now we'll see how we are going to construct LR0 parts table. So now let's solve this. Then we'll get to know, like we'll try to remember some points here. Okay. So let's take this is the grammar G. Now we have to construct LR0 parts table, and we have to check whether the grammar is LR0 grammar or not. Okay. If you are able to construct LR0 parts table efficiently in the sense, every cell, what is the parts table we are going to be constructed? If every cell having only one production, then we can say the grammar will be the corresponding, the parser will allows the to construct the part G for the strings generated by the grammar. Okay. So let us say this is the grammar G, and when we can call this is the LR0 grammar is if all the strings which are generated by this grammar, if we are able to construct parts G with the help of LR0 parser, then we can say that the grammar G is the LR0 grammar. Okay, LL1 grammar, SLR1 grammar, like that. Okay, so even though if LL1 is also like for all the grammar, if you are able to construct parts G by using a specific parser, then we can call that grammar is a LR0 or whatever that will be related to it. Okay, so now just we'll see like how to construct a DFA for it. Okay, so as this is a grammar G, what is the first step we have to do? That is, we have to add some augmented grammar, right? So what is the augmented grammar? We just need to add one production where this starting symbol will be the right part of that specific production. Okay, so let me add this augmented production, that is s dash derives yes. Okay, So for every in this seller zero parcel construction, we have to we have to compute the closure and go to function. So for every closure, we have to add the productions with dot as one some marker we should include in the right hand side of the production. That production we can call it as a compiler item. So let's say we are going to introduce augmented grammar. So as a part of it, we are introducing one grammar, that is s dash derives dot s. Okay, so don't get confused here. uh, some in some materials they'll give augmented production will be s dash derives dot s. In some reference materials they are giving s dash derives dot s dollar, because if you take the starting symbol, the concept here is in the bottom of parsing, the concept here is there will be a string w, and maybe supposed to reduce the string w to s, right? So if you take any specific string, always the string has to be followed with the end of character, right? The same way, if you are trying to construct parsing for the string w, at any step after reductions, always the dollar will use to the dollar will follow this string w follows the dollar, right? And in the same way, if you are reaching at the end, like we'll be left with the starting symbol s, the starting symbol s always will follows the dollar, right? So for that purpose, in some reference materials they are adding dollar after s in the augmented production. That is up to you. You can use this production as a new production which you are going to introduce, and even this also, either this or this, anyone is fine. Okay, in some in Woolman textbooks they are following this, in some other materials they are following this. No problem with this. Okay, you can go for either first option or you can go for the second option. And now we'll see how we have to construct this. Okay, so in the next slide we'll try to add augmented grammar. Let's take I have introduced the augmented production, that is s dash derives dot is, I'm not writing dollar because I have habituated to write I have not habituated to write dollar. Okay, so see here, this is the newly introduced production in a closure I know. Let me write it as a I know. Let me write it as I know. So in this I note, I have introduced a newly introduced production. So in this newly introduced production, after dot we are having s, right? So now I have to add s production. What are s production here? What are s production? These two are the s production, right? So now I'll do one thing. Not this. S productions I will add here. S rice. I have to add LR productions like compiler item. S rice parenthesis shell and S rice. What is the other production? I think it's ID. So these two S productions I have added. And what are other productions? The other productions are L derives S and L derives L comma S. L derives S dot S and L derives dot L comma S. Okay, so generally this is the mistake we're supposed to do. In the what is the closer definition? In the closer definition, if there is a production like A derives alpha dot capital B beta, if this is in the closure, what we have to do? After dot we are having B, means we in future we may read the B production. So that's what we have to include the B productions in the closure itself. Okay. So whenever I have to include the B production, if you have seen B symbol as a next symbol to the dot, then only I have to include the B productions here. But if you see here in this closure I naught, in this closure I naught, and see here, we are having, after dot we are having S. So I have included S production. What are S production? These two are S production. So these two are newly introduced. So dot will be at the beginning, okay, beginning of the right hand side production. And after dot there is a open parenthesis, so no need to add any other production. And after dot we are having id here. Okay, so no need to add any other production because these two are terminals, right? So how I can join, like I can add this L production, this is not going to be added. Okay, you please remember this point, because like while defining the closure, we have to include the productions, only the production which the symbol which you are going to see after next to the dot operator. Okay, even though these L productions are defined in the grammar G, this is in the grammar G, we are not including in the I naught, right? Because we don't have a provision to add these L productions in the I naught itself. So that's what this is a common mistake we will do. Okay. So this is not the right one. We cannot add L production because we don't have the provision here to add L production. So now this is the I naught itself. Okay. So now we'll close it. So this is the I naught. So now from this I naught, we have to define the go to functions. Okay. Here I'm not I'm not writing the close go to function. Just I'm defining here. Okay. So see here on S, on S I'll define. So on S, what is the production I have to select? I have to select this production, right? Because after that we're having S here. So I'm making the transition, or I'm making the go to function on this S symbol. So in such case, I have to consider all the production where S is a next symbol to the dot operator. Okay. So this is a one production. Now this one I'm going to consider here. So now this can be converted like S dash derives S dot. Okay. Dot can be shifted to next to the the symbol which you have defined the transition. Okay, I have defined on S, so that was this dot is shifted to next to S. Okay. If there is a dollar, we will be getting dollar here, and again we may define the transition on dollar. Okay, so this is one state, and now we'll see for this state, and here we can define on open parenthesis. Okay, open parenthesis, we are going to define the transition. And now this can be converted like, can you tell me what is the production we will get it here? We will be getting st rise. This is the open parenthesis. Now this dot can be shifted next to open parenthesis. Okay, then L, then dollar. And see here, now this is the production we got in the closure. And in this closure, after dot, we're having L here. So you have to add the L production. What are the L productions? These two are the L productions, right? L derives S and L derives L comma S. Okay. So now you have to add L derives S and L derives dot L comma S. These two are the newly added production. And see here, this is the newly added production. And after that, we are having S here. So we have to include again S productions. Okay. So what are S production? These two are the S productions. So include S productions again. Means in the way you have to cross check for every newly added production. Open parenthesis L and S derives ID. Okay. So we have added these two production with respect to this production, right? And the next production we have added is this L derives dot L comma S. And here after dot we are having L here. So we have to add the L production. If I add the L productions, then what we may get? We may get the same productions, right? Same set of productions, right? So in that case, no need to allow the repetition. Okay, no need to allow the repetition. So you can keep the same L productions here. No need to add repetition is not going to be allowed here. And here again, here also, this is the newly added production, and after that we are having terminal, and here also after that we are having terminal, so no need to add. So now you can close this closure. Okay, and next one, so here only one transition has been left out here, so that is on id. Okay, so this is the transition on id. Then how the production is going to be changed? So now here we are getting sd rise id dot. Okay, so here id transition we are making, this dot can be shifted here. Okay. At one level, we have defined like all the clauses. We have collected the canonical collection here. So now you can name it here. This is I know. This is I1. Even names also, no need to start from zero and no need to give this as I1. That is up to you. Like whatever the convention you have followed, the same convention need to be followed till the end. Okay. So I1, this is I2, and this is I3. Okay. So at one level, we got this canonical collection, and now we'll define for others. So as I1 is final, right? Because this is the state where the reduction is going to happen, where we are reducing the starting symbol S to S dash. Okay. So now we'll see on I2. On I2, we'll define the transition. So which one we have? First we're having, after that we're having L, right? Now we'll try to define for construct go to on L, go to on L from item I2. Okay. So now the question is how many, which production I have to consider? Which production I have to consider? Can anyone tell me? And see here we are having, after that we are having L here. So this one I have to consider. So SD lines, open parenthesis, L, this dot can be shifted, close the parenthesis. Okay. And next one, next transition is what? Next transition is defined on S. So yes, transition on yes, it can be shifted to L derives. Oh, okay, here, right? L derives yes dot. Okay, no other S productions. We can close it here. And see here again, what is the next go to function I have to define? Next go to function I have to define is L, right? Again L, then I'll get L derives L dot comma S. Okay. But see here, as we are constructing DFA, so we are making I naught, I1, I2, all the different states of DFA. Can we have transition, like can we have two transition emerging from the same state? This is like, let us take there is a state Q2. From the state Q2, can you define a 2A transition? 1A transition is going to some towards Q0. Some other transition is going towards Q3. Is it allowed in the DFA? DFA. Is it allowed? Can anyone give the answer to this question? As this is a Q2 is the one of the state in DFA. Can I define transition on same symbol to the different states? No, this is not going to be allowed. Right? Then if this is happened, then it will violate the determinism concept. Okay. So here the transition is defined for only one symbol. Okay, not more than that. And in on one transition, we should go for only one step. And see here, now this is not going to be allowed. Okay, just I'll try to remove this. So you have to make only one transition. One transition means, so while making the transition on L, you have to consider all the productions where L is the next symbol for the dot operator. So this one I have considered. Even this is also you have to consider and you have to include in the state itself. Okay. So now this can be converted like L derives. This dot can be shifted to next to L, then a comma, okay, comma, yes, this is comma, okay. So now this is the next state and this is the state, and here we'll try to define on what is the other transition which this one we have considered, and now we'll consider this open parenthesis. So in the open parenthesis, how the production will be converted? See here, next derives open parenthesis dot L, right? After dot we're having L, excuse me. After dot we're having L, so I have to include L productions. L productions means these two I have to include. L derives dot S and L derives dot L comma S. Again, these two are newly added production. So after dot we are having S here. So you have to include again S production. What are S production? S derives dot L, again S derives side. This is same like this I2, right? So again, now no need to repeat this step, okay? Because the same productions along with the dot symbol we are getting if you are defining the goto function on dollar, sorry, on open parenthesis from I2, we are getting the same state. So that's what you can write, instead of writing again, you just declare it as I2. Okay. And from this, so from this state, and I'm defining goto function on ID from I2. So what is the next state I'll get? I'll get SDLS ID dotted. This is same like I3, right? So just define I3. Okay, so these are the few changes, like a few points we have to remember. Don't copy paste all the productions from grammar to I not. Okay, so we have to include only the productions where we are seeing after dot somebody is seeing, then only we have to add the productions. Okay, so now we'll complete the next one. So now I'll name this canonical collection as second level we have completed, and from I3 no need to give the extended transitions. I1, I2, I3, and this is I4. Let me name it, and this is I5. Even I5 is also final item, right? Because I can reduce S to capital. Now we'll define transition on I4. Okay. So from I4, I'll define transition on closed parenthesis. So if this is a closed parenthesis, now this can be changed like this production can be changed like SD rise in parenthesis L closed parenthesis, right? So this is also closed. This is also reduced item. We can call it as a final item. SD rise and okay. So now we'll define transition on second production we have left out. Now we'll define transition on comma. Okay, comma. Now this will be changed like this production can be written as L derise L comma. So this dot can be shifted to next to this is comma and this is yes, right? So now this yes, I'll reduce the space. Then it will be easy to define the transition later. So now this can be written as L derise L comma dot S, and after dot we're having S production. After dot we're having S here. So you have to include S production. What are S production? S derise dot parenthesis here S derise dot ID. So this is the state, and after dot here we are having both the terminals, so no need to add. Okay. So now this is at the other level. Now again I'll name it the canonical collection. I5 no need to define. I2, I3 done. It's done. I5. This is I6, I6, and this is I7. Okay. So now from this again we have to define transition on S, right? First transition on S. So now if it is yes, the production will be written as L derise L comma. This dot can be shifted after next to S. Okay, next to S. So this is also one final item, reduced item. Next we have to define on this open parenthesis. If I'm defining open parenthesis, the next production will be S derise parenthesis dot L. I have to add dot production, means this is the state we'll get again. Okay, so no need to write it. Just I'll mention it as a ID. And here again there will be ID. So here you can mention it as a ID. Okay. So if you want to construct now, this is the final. This is the final DFA we have constructed. Whatever the names you have followed, you have to follow for further, further concepts. So now, shall we draw the DFA? So let me write the DFA. Okay. So this is the DFA. So if you want, just you can take the state names instead of Q0, Q1, and Q2. Just you can define the states I0, I1, I2, I3, I4, I5, I6, I7, and I8. Final state will be I1 anyway. Okay. And these are the states where where reduction is going to happen, reduction action is going to happen, and the transition can be defined on terminals as well as the non-terminals also. So from the I naught, the transition can be defined on S, open parenthesis, ID, and I1, there will be no transition emerging from it, and from I2, there are the four transitions on capital L, capital S, open parenthesis, and ID. Then you may convert this DFA, this canonical collection into DFA without productions also. Okay, so now we'll see how to construct LR0 parts table for this DFA. Okay, here I have given the basic skeleton here. So these are the items we got I0 to I9, and corresponding to action we have to specify what are all terminals we got. All the terminals are open parenthesis, close parenthesis, comma, ID as well as a dollar, and in the go to part we are going to mention the non-terminals. Okay, so that is like L and S, we are going to write it here. Clear? So now we will fill these actions. What are the actions we have to fill? While filling these actions, we have to see from the state if the go-to function is defined on variable, we have to mention in the go-to part. Okay. So if it is defined on the terminal part, then we have to specify some shift action here. And which state is going to have the final item or reduction item, then we have to fill reduce action. Okay. So now we'll fill corresponding to I naught. Just pay attention here how to fill. See here I naught on yes. So it's a variable. Just going to the state is enough. And I naught on open parenthesis. This is a term here. Shifting action can be done here. We have to shift this open parenthesis onto the stack. And next you have to move to just move to the state I2. Okay, and from I naught, if you are seeing that like terminal ID, then this ID has to be shifted onto the stack. Then you have to move to the state I3. Okay, that's the concept here. So whenever you are making transition on or to some terminal, all these terminals can be pushed onto the stack. And if you are making transition on the non-terminals, then the transition has to be moved to the next state on. Clear? So now you can see here from the state I naught, I'm making the transition on yes. So where I have to fill I naught on yes, I naught on yes. This is the state. I have to fill one here. Means I'm going to state I1. Okay. And next one. I naught on open parenthesis. I have to perform shift action. Means this open parenthesis I have to shift onto the stack. Then I have to move to the state I2. So I'm going to write S2 here. I naught on open parenthesis. You have to perform the shift action, and you have to move to the I2 state. Next, I naught on ID shift action, and you have to move to I3. Okay. I naught on ID. You have to move to you have to shift this ID and move to S3. Can I fill all? And the I1 and corresponding to I1 state, we have to, as this is the final acceptance state. So corresponding to I1 and dollar, I have to fill it as the acceptance state. So that is the acceptance action. Next to I2. High to state. I think now you are having idea, no, what you have to do. If you are seeing some non-terminals, then you have to place it in the go-to part. If you are seeing terminal part, you have to specify what action you have to place, and next what is the next state you should make a move. Okay? So there's a question here. So I know I2 on L, I4, and I2 on S, I5. Okay, I2 on S will be 5, and I2 on L will be 4. And here I2 on open parenthesis will be S2, and the next I2 on ID will be S3. In the same way, I'm going to fill for all the states. I think now you're having idea, no? Just I'm filling this table, because again moving from here to there, it will create some problem. So we'll see for I3 here. So for I3, what is the action I have to take? I3 item having some final item here. I3 state having some final item here. So corresponding to this final item, I have to place the reduce action. So again, while if I say reduction, we'll be getting confused like which production I have to reduce. So that's what for the productions you give numbering, and corresponding to that production, you can place a numbering here. 1, 2, 3, 4. Okay. So see here. So in this state, SD drive ID. So which production it is? This is the production SD drive side. This is second production, no? So you have to place reduction action. So which reduction action? R2 you have to mention. Okay. So here I'll write and corresponding to I3. Where I have to place this R2 action, you have to place corresponding to all the terminals specified in the action part with respect to the state itself. Means for with respect to I3, what are all terminals you have specified in the action part, you have to place in the you have to place the action R2. R2. You have to place R2. You have to place R2. Okay. So next I4 part. And coming to I4, shall we see? I4. I4 on closed parenthesis, I5. Sorry, this is I6. This is I6. Don't get confused. I6 and on comma I7. I4 on closed parenthesis. That is I6, right? So anyway, it is a shift action. Shift action S6. And I4 on what is the other variable? Comma, right? So shift action and as well as 7. Only two transitions are defined from I4. Next we'll see for I5. Okay. And C5, I5 is also having one final reducer production. And what is the number corresponding to it? The number corresponding to it, this is I think third production, right? So I'll write R3 correspond to I5. R3, 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 and here R3. So in the same way for I6. And for I6, we are having what is the state? I6. This is I6 and this is the first production, right? So you have to enter R1, 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 and R1. Okay. Next I7. So this is the I7 state. On yes, open parenthesis as well as ID. On yes, it is going to I8. On yes, it will be 8. On open parenthesis, it is going to I2. Next I7 on ID, it is going to S3. Okay. So next I8. So what is I8? I think I8 is also one reduced item, right? Final item. So you have to place. This is the L production, and this can be, I think fourth production, right? So you have to enter R4. We are having four productions here. R1, R2, R3 is done. Now we have to place R4 corresponding to I2. R4, R4. Here also you have to write R4. See here in this window I am getting this. So that's what I am not writing. So R4. So corresponding to here and here also I have to write. This window is not allowing me to write it here. Okay, here you have to write R4 and I4, R4. So this is the LR0 part stable filling. And now we'll see how to map the string, how to construct the string. So let me take one string that can be formed with this grammar. Can you suggest one string that can be derived with this? Can you give one string? Anyway, L having L comma S said again L having parenthesis. So let me take this. Open parenthesis ID comma ID. Is the grammar is going to generate this string? Yes or no? Can you cross check? Can you cross check please? Yes, right? Okay. Now we'll see how to do the parsing in the bottom of parsing. Okay. Now this parsing procedure is common for all the four bottom of parsers. Okay. Just pay attention and observe here what how we are doing. Okay. And see here. And here I have written. So this is the string. So initially we should we'll be at the stack point, and what is the input? The input is this. open parenthesis, open parenthesis. ID is together is one token, one lookhead. Okay, ID, or instead of ID, you can take some any other variable also. It's not a problem. It's not a deal. Okay, dollar. This is the input. Initially stack at the I naught stage. Generally, we are not going to enter the states onto the stack. What we have to enter onto the stack? We have to enter the locate symbols only. Okay, not the state. Just for our reference, I'm writing some with the small notations. Okay, so initially we are at I naught in the starting state. So now we have to check I naught and what is the locate symbol here? The locate symbol is doll. Open parenthesis, right? Let me write in the blank. The locate symbol is open parenthesis. So now we have to consult the table. I naught on open parenthesis. Okay. So what is the action you have to perform? I naught on open parenthesis. What is the action you have to perform? The action is S2. S2 means you have to shift. Just I'm writing S here. Okay. It is not allowing me to write some sentence. Just I'll write the action. Okay. So what is the action? The action is S2. Here. Action is S2. S2 means you have to shift the lookup symbol into the stack and you need to move to the state I2. That's the meaning here. Getting here S2 means we have to shift the lookup symbol as the top of the symbol and we need to move to the state I2. That's the meaning here S2 means. And now the stack state is 0. Okay. But this 0 is not appears on the stack. Please remember this. Okay. So shift action. What is the lookup symbol now? Open parenthesis is the lookup symbol. So open parenthesis can be moved on to the stack. We have to go to the state I2. Okay. This 2 is not shifted. Just for our reference, I'm writing. Okay. This is 2. And now go to the top of the stack. Top of the stack is this open parenthesis, not the 2. Okay. This is just for our reference. Or you can make it as a current state. Okay. We have to, we have to maintain one queue data structure here to keep track of what is the state of what is the current state, what is the previous state, what is the next state. Okay. While doing the programming concept here, while doing the programming for this concept, we have to make or you have to create one data structure to indicate what is the previous state and what the current state, what will be the next state. Okay. So that we can monitor with the linked list concepts. As of now, what is the top of the stack? Only open parenthesis, not the 2. This is our reference. Yeah, can you cross check please? Okay, no? Yeah, okay. And we have moved it, no? And what is the next symbol here? Meanwhile, now this open parenthesis I have pushed onto the stack, right? Now, now we left with open parenthesis, ID, close the parenthesis, comma, ID, and close the parenthesis, dollar. We left with this input string. So what is the next state we have? What is the next action we have to perform? We are in the I2 state, and the lookup symbol is open parenthesis. I2 and open parenthesis. I2 and open parenthesis. What is the action? Again, S2 action. Okay, S2 means I'll mention here. First, I'll write S2 here. S2. S2 means shift the lookup symbol and move to the state I2. That's the meaning here. So 0, open parenthesis, these two, shift the lookup symbol. Lookup symbol is open parenthesis. Open parenthesis, I'm shifting here and I go to I2. So I2 will be the next step. I again, please remember here, these two are not the stack symbols. Just for our reference, I'm writing here. Okay. And now the input ID, close the parenthesis, comma, ID, close the parenthesis, dollar. Okay. It means we are processing this input string. We are here, we are here. Now we are about to read the string, read the lookup ID. Now the lookup is ID. And what the current state? I2. Now we have to see what action we have to perform. I2 on ID. Okay. I2 state on ID. What is the action we have to perform? We have to perform action S3. S3 means shift the lookhead. The lookhead is ID now. ID we have to shift onto the stack. 0, close the parenthesis. This 2, sorry, open parenthesis. This 2. We have to shift the lookhead, right? Lookhead is ID. I'm shifting ID onto the stack. Okay. So next I have to move to the state I3. So these three I'm writing in very small numbers. And now the input is closure parenthesis, comma, ID, closure parenthesis, dot. Okay. So now what is the state? In which state we are in? In which state we are in? The current state is I3. And what is the lookhead? Lookhead is closure parenthesis. I3 on closure parenthesis. I3 on closure parenthesis. What is the action? The action is R2. Okay, now let me write it. The action is R2. R2 means what? R2 means we have to reduce the top of the stack. What is the top of the stack? This ID. It means from the topmost symbols of the stack, you can able to reduce, it means whenever you have found some action R, it means from the topmost symbol of the stack, you have found one token. That's the meaning here. Okay. So what is R2? Now we'll see what is R2. Generally, we are not going to see R2 and all. By with the programming itself, we'll get R2 means what? ID value we have to reduce to S. That's the meaning here. Okay. ID value we have to reduce to S. Means this is a lookup symbol. This ID is handle. We have found some handle here. Handle is ID. ID is matching with this part. Now I am reducing ID to S. That's the meaning. It means from the topmost symbol of the stack, you have to pop up the symbol. Which part is handle? That handle you have to pop from the stack. In place of that handle, you have to push the leftmost variable. Clear? So now 0, open parenthesis, 2, open parenthesis, 2. What is the topmost symbol of the stack? ID. Now ID you can pop. In place of that ID, you can push the left hand side value. Means yes. Yes, you have to push onto the stack. And here, what is the next step? How to define the next step? Okay. So in this part, you have to depend on go to slot. Okay. Till now we have depended on this action parts, right? Now, whenever a reduction is happening, then go to will help you out to move to the next state. Okay. Go to will always give you the next state whenever the reduction is happened. Okay, please remember this point. This action will be given in order to, like, if you are seeing some terminal or non-terminal, whatever it may be, from a look at symbol, the action will tell you either I have to perform shift or reduce or accept or other. But this go to will define you to which state I have to move after the reduction. That's the concept of go to here. And now see here, the reduction is happened here, means the previous state is I2. So on I2, from I2 state on S, what is the next state? So for this purpose, I have written this 2 here. Okay. What is the previous state for it? Previous state of it is I2. So the reduced value is S. Now I2 on S, what is the state? I2 on yes. What is the next step? 5. Getting? So this go to will help you out when reduction is happened. So I2 on yes, it is saying the state will be 5. Okay. Just I'm writing with the small value. Yeah. So what is the input now? The input is at the same level. Okay. So the current state is I5, and like the lookup symbol is closed parenthesis. I5 and closed parenthesis. That's the task. I5 on closed parenthesis. What is the action? R3 action. R3 means R3 means this L derives S, right? This R3 means R3 we have to mention. L derives S means this S can be reduced to L. That's the meaning. Okay. So I'll write it here. Zeroth state, open parenthesis, I2, open parenthesis, I2. You pop this S. Okay, because this S is handle now. L derives S. Okay, L derives S production. So from S we have found as a handle. Now you pop this in place of S, you have to push L here. And how to define the next state? You just has to define what is the previous state of it. What is the previous state of it? L. Sorry, I2, right? I2 on L. What is the next state? Where is the meaning? I2 on capital L. What is the next state? I4. 4. Means it is saying we have to go to the fourth item. And now look at this, close the parenthesis, ID as well as dollar. Okay. So now I4 on close the parenthesis. I4 on close the parenthesis. What is the action? S6. S6. S6 means you shift this lookahead and go to the sixth state. 0, 2, 2, L, 4. What is the lookahead symbol? Close the parenthesis and go to sixth state. And what is the lookahead now? The lookahead is comma now because this close the parenthesis shifted now. Now lookahead symbol is this. Now I6 on comma. I6 comma. I6 comma. What is the action? R1. Action is R1. R1 means first production. What is the first production? What is the first production? The first production is S derived cell. Means this is the string we have. We got this handle from the input tag. That's the meaning here. We have found this handle from the input tag. S derives open. Sorry, S derives open parenthesis cell. That's the meaning here. Sorry, here. Okay. Open parenthesis means this open parenthesis. Sorry, this open parenthesis L and this open parenthesis all together is S. Okay. So now what we have to do? We have to pop the symbols. We have to pop till we are getting open parenthesis from the topmost symbol of the stack. Means you have to pop out, close the parenthesis, you have to pop L and you have to pop open parenthesis from the stack. So this part we have to, this part we have to pop up from the stack. So in this all the part. Not 2, 4, 6, but open parenthesis, then close the parenthesis. We have to pop up from the stack. And in place of that 0, open parenthesis, 2, and in place of that, what is the left hand side variable of it? Yes. Yes, I have to push. Now reduction happened, right? So what is the next step? How to determine it? You just get to know what is the previous state of it. What is the previous state? I2. I2 on yes. The next state is 5. Okay, that you have to consider the parts table then. And here comma, ID, close the parenthesis, and dot. And now the lookahead is close the parenthesis. We are in I5. I5 on closed parenthesis. Sorry, I5 on comma. I5 and comma. The action is R3. R3 means again. R3 means S can be reduced to L. Okay. R3 means S can be reduced to L. Now 0 open parenthesis. You have to pop top of the stack means S from the stack. In place of S, you have to place L. L. And what is the next step? You just get to know what is the previous state, that is I2. I2 on capital L. What is the next state? I2 on capital L. The next state is 4. Okay. So I have notebook here. So that's what I'm directly writing here. Instead of going here and there, just I'm writing. Okay. So this comma, ID, close parenthesis, dollar. And what the next action I have to perform? I4 and comma. I4 and comma. I4 and comma. We are having the action S7. S7 means shift that look head 0 open parenthesis 2 L 4 shift that look head. Look head is comma comma. Then go to 7th state. Then we'll be left with ID only. ID close the parenthesis dollar. Then what is the next action I have to perform? I7 on ID. Okay, I7 on ID. I7 on ID. The action mentioned is S3. Or if you have noted down that parts table, no, you just see that parts table and you just try to get the action here. S3. S3 means shift this look head. Okay, that's the meaning. Shift this look head. 0 open parenthesis 2 L 4. This is comma 7. Shift that look head. Look head is what? ID. ID. Then go to the state 7. And now here we will be left with closed parenthesis and dollar. Now we are at I7 and closed parenthesis. I7 on closed parenthesis. What is the action? I7 on closed parenthesis. Is it closed parenthesis? No. This is defined it as error. So we did a mistake.
I3 మ్యామ్.
ఎక్కడమ్మా?
ఐడి తర్వాత 3.
ఇక్కడ.
ఎస్ మ్యామ్. S3
Yeah,
కదా? ఎస్ మ్యామ్.
S3, right? Yeah, this is S3, right? So, sorry, ID S3. Okay, so now we'll see. I3 on closed parenthesis. I3 on closed parenthesis. We got R2, right? Cross check చేయండి అన్న ఒకసారి. R2. R2 means second production. What is the second production? The second production, I think, S derives ID, no? So now it means this ID has been matched with yes. Okay, reduction means you just pop out the top of the stack. This is open parenthesis 2 L 4 comma 7. This is comma. So this ID has been reduced. Means this has been reduced to S. So what is the next state? Next state will be defined from the previous state. So I7 on S. I7 on S. It is giving 8. I7 on S. It is giving 8. We are here. Look head is dollar. And now we have to cross check. I8 on closed parenthesis. I8 on closed parenthesis. The action specified is R4. Okay. R4 means the reduction action. What is the R4? Just to know R4. Fourth production. L comma S. Okay. So we have to pop the top of the stack till we are able to form L comma S. Okay. So L comma S means this L comma yes. Okay. So you pop all the symbols. 0 open parenthesis 2. This S can be popped from the stack, comma can be popped from the stack, L can be popped from the stack. L comma S. In place of L comma S, I have to place L or S. You think L, right? L. L. L namma. Yes, it's L. This is L. This is L. Now I2 on L. I2 on L is 4. Okay. So look head is still the look head we are getting is closed parenthesis. Now I4 on closed parenthesis. I4 on closed parenthesis. It is saying S6. S6. S6 means shift that look head means 0 open parenthesis 2. Can I write it in the next slide? I get it here. 0, open parenthesis, 2, L comma 4, L, not comma, L, 4. What is the next action? S6, right? S6 means this closed parenthesis will be shifted onto the stack. Shift S6, no? So 6. And coming to the input, now we have sent this closed parenthesis to the stack. So the lookhad is dollar now. Okay. Now we'll see we are at the state of I6 now. I6 on dollar we'll see. I6 on dollar. The action corresponding to it is R1. R1 means first production. What is the first production? Parenthesis L can be reduced to S, right? Is it? What is the first production? Yes. Parenthesis L is reduced to S. Okay. So here, this parenthesis L, closed parenthesis, can be reduced to S. Have I reached the start symbol? R1. R1 means we have to, we have to pop up the symbol till we are able to form this open parenthesis L. Means open parenthesis L, close parenthesis means till this we are going to pop down. So in place of this, we are going to enter S. Okay. So what is the next state we have to define? I naught on yes. Previous state is 0. I naught on yes. I naught on sorry. I naught on yes. I naught on yes. It is giving the state 1 and the input the lookhad is dollar now. So now we are at the state I1 and we are seeing the dollar. I1 on dollar. So the action we have to perform is accept. So see here. By that time we are able to reach the start symbol here. Okay. So if you have taken the string which is a part of this grammar, definitely we will end up with this start symbol. Okay. So otherwise, we'll be leading to the cell where there is no action, nothing. Okay. Suppose if you have taken some other string which is not part of the grammar, we'll be leading to these states, empty states. If you are leading to this empty statements, we cannot proceed. We cannot go further. Okay. This is like ambiguity. It's not ambiguity. This is a halting step. Okay. All these empty cells are the halting steps. Unfortunately, if you have reached this statement, furtherly we cannot proceed. We cannot go further. That's the dead end. Okay. So we have taken one string which is a part of this grammar. So that's what nicely we have reached the start symbol here, and in the tracing also we got the accept condition. Otherwise, we'll be leading to the other conditions. So this point I want to discuss with you all, and this procedure is common for all the four parsers. Okay. So where we will get the difference is as a partially is going to have some action part and go to part. This go to part will help you out whenever there is a reduction, and this action part will help you out if any transition is emerging from on a particular state on the terminal. Clear? Any doubts? So for the next class, in the LL1, I have given you few problems, right? To solve LL1 grammar, I have given you few problems, nearly 15 problems I have given, I think. So you please construct LR parts table for all the problems. Okay. How you will construct is just, let's take this is your notebook. Okay. Let's take, this is two-sided. Okay. This is the, you can able to see this and this at a time, then it will be very easy. Okay, you start the problem here. Okay, you write grammar here and you construct DFA here. Okay, so by see this DFA, and by seeing this DFA you can construct LR0 parts table in the first half of the second page. Okay, and the remaining page you leave because SLR1 parser is also same as LR0 only with small differences. Okay. So what you will do is in a half part you construct the table for LR0, half part you leave, and after discussion after discussing SLR1, then you can fill this area. because this SLR is also referring the same DFA which we have constructed for LR0. Are you getting? So you start the, if you are solving problems, then you start from this page and construct DFA here, LR0 here, SLR1 here. Anyway, other passes are going to vary, parse tables are going to vary. So that's what. Anyway, at least these two DFAs are common. So that's what I'm suggesting. And just take a snapshot of it and you can do on your own. Construct LR0 parts table for all these 6 problems. If you are really interested, no, you can solve with the other problems that we have given in the last classes. Take a snapshot of it. లేదు మీకు ఓపిక ఉంది అంటే నోట్ చేసుకోండి. Clear? If we solve this now, you will get more doubts. Then we'll discuss. And one common example will be there, no, like this one. This one you will get more states. For some problems you will get more states. అలాంటప్పుడు ఏం చేస్తారంటే ఈ బుక్ ఇలా ఉంటుంది కదా, ఇలా తిప్పేసి రాయండి. నోట్బుక్ ఇలా ఉంటే ఇలా తీసుకొని, జనరల్గా అయితే ఇలా 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 రాస్తాం కదా, ఇది లెఫ్ట్ మార్జ్ అనుకుంటాం కదా, సో ఇలా తిప్పేసి రాయండి. ఇక్కడ డిఎఫ్ఏ కన్స్ట్రక్ట్ చేయండి ఈ ఏరియాలో, ఎందుకంటే ఇలా పెద్దగా వస్తుంది. అది ఇక్కడ స్టార్ట్ చేశారనుకోండి, మళ్ళీ ఇలా వెళ్ళిపోతాయి స్టేట్స్. మీ గ్రామర్ కొంచెం ఎక్కువ ప్రొడక్షన్స్ ఉన్నాయనిపిస్తే ఇలా స్టార్ట్ చేయండి. ఇలా స్టార్ట్ చేసి ఇక్కడ డిఎఫ్ఏ డ్రా చేసి ఇక్కడ టేబుల్స్, ఇక్కడ ఒక టేబులే వస్తుంది, LR0 SLR1, ఎందుకంటే మళ్ళీ స్పేస్ ఎక్కువైంది. లేదు అంటే దీన్ని కూడా పార్టిషన్ చేసుకొని ఇక్కడ LR చేసుకోండి, ఇక్కడ SLR చేసుకోండి. ఓకే, ఏంటంటే ఈ ప్రాబ్లమ్స్ అన్ని చేశారనుకోండి, దెన్ యూ విల్ బి ఏబుల్ టు బ్రింగ్ ఎ రిలేషన్ బిట్వీన్ ఆల్ పార్సెస్. LL1 సేమ్ అదే గ్రామర్ కి LL1 చేసి ఉంటారు, ఇప్పుడు LR0 చేస్తారు కదా. సో బేస్డ్ ఆన్ దీస్ టూ ఏమవుతుందంటే యూ కెన్ ఏబుల్ టు డిరైవ్ ద రిలేషన్ బిట్వీన్ LL1 అండ్ LR0, whether LL1 is subpart of LR0 or LR0 is subpart of LL1, or both there will be no relation between LL1 and LR0, or there is a common relation between LL1 and LR0. This you can able to derive if you have solved all the problems. Okay, this relation I am not going to discuss with you, because after solving problems, no, you will come to one common conclusion. మీరు ఆల్రెడీ LL1 కి ఇచ్చిన ప్రాబ్లమ్స్ ఉన్నాయి కదా, దానికే LR0 చేశారనుకోండి, దెన్ యూ విల్ గెట్ టు నో వాట్ ఇస్ ద రిలేషన్ బిట్వీన్ దిస్ LL1 అండ్ LR0. ఇన్ ద సేమ్ వే ఫర్ ద సేమ్ ప్రాబ్లమ్స్ విల్ కంటిన్యూ ఫర్ SLR అండ్ CLR అండ్ LALR. అవి కూడా చేశారనుకోండి, మీకు మీరే రిలేషన్ డిరైవ్ చేస్తే యూ విల్ నెవర్ ఫర్గెట్. If I have given some statements, no, what you will do is simply you will by heart before going to exam, and you'll write there. Then these points will be vanished. మీరు ఓన్గా డిరైవ్ చేసుకుంటే ఇంకెప్పటికీ మీకు గుర్తుంటుంది. ఓకే, ఏమైనా డౌట్స్ ఉన్నాయమ్మా? సో I'll move this to this part again. ఇంకెవరైనా నోట్ చేసుకోలేదు అనుకుంటే ఇది స్నాప్షాట్ తీసుకోండి ఒకసారి. క్లియర్? ఎనీ డౌట్స్? ఏదైనా డౌట్స్ ఉంటే యూ కెన్ ఆస్క్. Epsilon is a terminal or non-terminal? Epsilon is a terminal, but we are not going to write in the terminal part, because I'll share with you, because Definitely, like if you are taking this input now, in the input we are not going to get any epsilon, right? Where we'll get epsilon? If you want to nullify any variable, then only we'll get epsilon production. But in the input, we don't have like we are never going to get any epsilons in the input. But that input is going to be helpful to vanish some variables. Okay, so that's what we are not mentioning. Epsilon in the parts table. That's what we are not mentioning here. But apart from it, dollar definitely will get it because as it is a end marker. Dollar కాదు end marker some ఏదో సింబల్ ఉంది అంటే instead of dollar we have to write the symbol as a end marker. ఓకే, మీకు ఎప్సిలాన్ ట్రాన్సిషన్స్ ఉన్నాయనుకోండి, ఫస్ట్ అండ్ ఫాలో గుర్తుంది కదా, సో అక్కడ మీకు నలిఫై అయిపోతుంది. ఓకేనా? షెల్ వి క్విట్? Yeah, you may leave then.